Hey guys, Mr. Backerberg here. In this video, we're going to look at exponents and the power rule. So when we're looking at the power rule, what we're actually going to be looking at is doing a power of a power. So we're going to see something with an exponent on it, but then we're going to be raising it to another power. So for example, here we have a squared, but then I'm putting another cubed power on that. Now before we get to what the actual rule is, I want to talk about what's happening in here. So we're taking a squared and we're cubing it. And what that means is that we're supposed to multiply a squared times itself 3 times. But then we have to remember that a squared really means that we're multiplying a by itself 2 times. And that's happening in each set in here. So all of these a squareds really mean a times a. Now, if we look at what's really happening in here, we're looking at multiplying all these different a's together. And because there's 6 of them, we could rewrite that as a to the 6th. So if we're looking at what's happening with these powers, with that 2 power being raised to another power of 3, what's actually happening in there is we end up multiplying those powers together, and that's how we get the 6th power. So the actual power rule says that you want to keep your base exactly the same as it is, but you want to multiply the exponents together. So if we look at what's happening in here with this first example, we've got 2 to the 5th power, but then we're raising that to another 3rd power. So using that power rule, this says that we're going to keep the base the same. So in this case, the 2 is the base, but we are supposed to multiply those exponents together. So we get 2 to the 15th power as our final answer. Now, because that's a base, that's a number, we could type this into our calculator using the caret key on our calculator. So we'd go 2 caret 15, and that's going to be a really, really big number. Now, if it is a really big number, we're okay to leave it with that exponent on there. But if it's a smaller number, then we might want to actually evaluate what this would be. But in this case, like I said, it's a really big number, so I would just leave my answer as 2 to the 15th power. Looking at this next one, we've got x squared being raised to the 4th power. So our rule says that we want to leave the base the same. So in this case, our base is x. We want to multiply these exponents together. So we would get x to the 8th power. Now in this example, we want to be a little bit careful because there's actually 2 things happening in here. Having this a and this b inside the parentheses means that we're doing a times b, and then we're raising this to the 3rd power. So I'm actually going to write this one out the long way first. So having a times b and raising that to the 3rd power would mean that we're doing a times b times a times b times another a times b. And then we've looked at the commutative property, which says that we're allowed to rearrange multiplication. So what I would do is I would rearrange this so that all of the a's are in the front and all of the b's are in the back. So these a's, where we're multiplying 3 of these together, that's going to be a cubed. And when we look at these b's, we're multiplying 3 of those together, so that's going to be b cubed. So what's actually happening in here, on this a, there's no exponent written, so that means that there's a 1st power. And on this b, there's also no exponent written, so that one also gets a 1st power. So when you have both of these things being raised to that 3rd power, we want to make sure that we're multiplying both of these exponents to the 3rd power. So we get the a to the 3rd power, and we also get the b to the 3rd power, because 1 times 3 is 3. So taking a look at this example, we have 24p being raised to the 8th power. Now there's no power on the 24, so that's an implied power of 1. And there's no power on the p, so that's also an implied power of 1. So when we multiply the exponents, we have to make sure that we're multiplying both of these exponents by the 8. So we're going to get 24 to the 8th power, and we're also going to get p to the 8th power. Now, 24 to the 8th power is going to be a really big number. So again, I would just leave my answer as is. If it were a smaller number, we could evaluate that using our calculator, but this big number, we're just going to leave it as 24 to the 8th power. Now this one we have to be extra careful on because now there's 3 pieces inside of our parenthesis. So we have to look at all of those powers. So on the 9, there's technically a 1st power. On the x, there's a 1st power. And on the y, there's a 1st power. And because we're raising all of that to the 2nd power, we have to make sure that we multiply all of these exponents. So the 9, when we multiply 1 times 2, we get a power of 2 on that. The x, when we multiply that 1 times 2, we get x squared. And the same thing with the y. When we multiply that 1 exponent by the 2, we get y squared. Now this is a case where we could figure out what 9 squared is in our calculator, or maybe we just know that. This is going to be a nice small number, so it's going to be easy for us to evaluate. So 9 squared is just 81, and then we have our x squared and our y squared. So here's a case where we have a nice small number to work with, so I would consider evaluating that using my calculator. Now, as we take a look at this example, I started to throw some negative exponents in there, so we do want to pay attention to our rules about negative exponents as we're going through and solving this one. Now, right now on that 4, there's no power, so there's an implied first power. On that x, there's the power of 2. On that y, there's that power of negative 3. So I'm going to raise all of that to this negative third power, so we're going to multiply those exponents together. So as far as the 4 goes, that has the first power on that, but if I multiply 1 by negative 3, I'm going to get negative 3. That x has a second power on it, but when I multiply that by negative 3, we end up getting x to the negative 6th power. And that y has a negative 3 power on it, so when I multiply negative 3 by negative 3, I get y to the 9th. Now, we had a rule about negative exponents that says we don't like to deal with them. So when we see negative exponents, we want to take those and drop those down to the bottom of a fraction. Now, when we do that with this 4, with that negative third power on it, we drop it down to the bottom, but then that power turns into a positive power. Same thing with the x. That has a negative power on it, so we drop it down to the bottom of the fraction, but then that power becomes positive. Now, this y already has a positive power on it, so I'm not going to move it at all. So that y to the 9th is going to stay on top of the fraction. Now, this is another case where we're going to be able to do this 4 to the third power and get a decently small number that we're working with. So we have y to the 9th on top. 4 to the third power is 64, and then we also have the x to the 6th on bottom. So for my final answer, we've got y to the 9th power over 64x to the 6th power. Okay, here's another example. So we've got 5x cubed y to the 4th, and that's all being squared. So right now on that 5, there's an implied first power. On that x, there's a third power. On that y, there's a fourth power. So we have to take all of these powers and multiply them by that 2 that's on the outside. So we get 5. When we multiply 1 times 2, we get to the second power. X, multiply the 3 by the 2, and we get to the 6th power. And y, multiply the 4 by the 2, and we get to the 8th power. Now, 5 squared we can either do in our calculator, or we might know that already. 5 squared is 25, and we have x to the 6th power and y to the 8th power. So that's going to be our final answer on this one. Now, that power rule also works if you're dealing with fractions. So here we've got the fraction a over b, and we're raising that whole thing to the third power. We still want to look at the exponents that are on each of our individual bases. So on that a, there's a power of 1, and on that b, there's a power of 1. So when I multiply these together, I have to multiply that 1 on the a by the 3, so we get a cubed. But then on the bottom, we have that b to the first power. Well, I also want to take that first power and multiply that by the 3 that's on the outside as well. So we would get b to the third power. So we multiplied both of those exponents by that 3. As we take a look at this one, very similar to the previous one, but now I've added a 2 power onto that a. So we've got a squared over b. There's still a first power on that b. We have this extra exponent of 5 on this whole thing, so we're going to have to multiply both of these exponents by that 5. So on top with that a squared, 2 times 5, well, that becomes a to the 10th power. And on bottom, b to the first power being raised to the 5th, we get b to the 5th power. So our final answer is a to the 10th over b to the 5th. As we take a look at this next one, we've got 4x to the negative 2nd power over 5y, and that's all being raised to the 3rd power. As we look at this one, we want to look at all of the powers on everything inside of the parentheses. So the 4 has a first power on it, the x has that negative 2, the 5 has a first power, and the y has a first power. So we have to multiply all of those exponents by this 3 exponent on the outside. So that 4 with the first power on it, multiply that by the 3, and we get 4 to the 3rd power. X with that negative 2 power on it, multiply that by the 3, we get x to the negative 6th. On bottom, 5 to the 1st power, well, multiply that 1 by the 3, and we get 5 to the 3rd power. And y to the 1st power, multiply that by the 3, and we get y to the 3rd power. Now, there's a couple of things that I notice in here. I notice that we have these numbers with the exponents on them, so I would consider evaluating those. 4 cubed is 64, and on bottom, 5 cubed is 125. Now I also notice on the top we have that x with the negative 6 power on it. So I want to take that and I want to turn that into a positive power. So to do that, we're going to have to drop that down to the bottom of our fraction. So we now have x to the 6th on bottom. But then we also still have this y cubed on bottom. And typically when we have multiple variables happening, we put them in alphabetical order. So that's why I put the x to the 6th in front of the y cubed. Now when we've got these fractions in here with numbers in them, we should always double check to see if we can reduce down our fractions at all. There is nothing that will divide nicely out of 64 and 125 though, so this is going to be our final answer. 64 over 125, x to the 6th power and y to the 3rd power. Now sometimes when you're dealing with fractions, you might notice that you're able to do some reducing right away. So on this one we have 9x squared over 3y to the negative 5th power, and all of that's being raised to the 4th power. I notice that we can do this 9 divided by 3. We can reduce that down. Both of these are divisible by 3, so 9 divided by 3 is 3, and 3 divided by 3 is just 1. Now that x squared is still an x squared, and that y to the negative 5th is still y to the negative 5th, and we're raising all of this to the 4th power. We want to look at the powers on these things individually, so we have that 3 being raised to a 1st power since there's nothing on it. That x is being raised to the 2nd power. This 1, there's no power on it, so it's to the 1st power, and y to the negative 5th power. Now, with all of those exponents, we want to multiply by this 4 on the outside. So with that 3, the 1 times the 4, we get 3 to the 4th power. The x, 2 times the 4, we get x to the 8th power. On bottom, with the 1 times 4 is 1 to the 4th power. And with the y to the negative 5th, negative 5 times 4 is negative 20. Now if we look at that 3 to the 4th power, 3 to the 4th power is 81. We have x to the 8th. On bottom, 1 to the 4th power is just 1, and then we have this y to the negative 20. Now what I notice in here is that we have this negative 20 power on that y. And we had a rule that said that we don't like to deal with negative exponents if we can get rid of them. And up to this point, we've always taken that negative exponent and we've dropped it down to the bottom of the fraction. But what I want you to notice about this one is that y to the negative 20, that's already on the bottom of the fraction. So we're going to have to do something a little bit different to get rid of this negative exponent. Since it's already on the bottom, to turn that power positive, we're actually going to take it and move it up to the top. So on top, we're going to get 81, x to the 8th power, and y to the positive 20th power. And this is all over 1. But because we're dividing by 1, we don't really need to leave the divided by 1 in there. So this is going to be 81, x to the 8th, and y to the 20th for our final answer. That's going to be it for this video. Thanks for watching.